All right, guys, you made it. Last day here. Okay, we're gonna start with determining if triangles are similar. So when I look at this one in part A, I'm hoping to use side angle side similarity. So I'm gonna do two fractions, 20 over 36, and then I'm gonna do 24 over 42, and hope these reduce to be the same. So this first one here, 20 and 36, we can divide both by 4, which gives me 5/9. And 24 and 42 we can divide by 6. 24 divided by 6 is 4. 42 divided by 6 is 7, which these are not the same. So this is not similar for my answer for part A. Okay, so part B, they're giving me 3 side lengths. So I'm going to set up 3 different fractions. I'll have 8 over, looks like 12.8. I'll have 10 over 16. And then the largest sides of each, 15 over 24. I'll start with these here. So 10 over 16, that divided by 2 gives me 5/8. 15 and 24 divided by 3 gives me 5/8. Okay, that's great. Now this one's a little bit trickier because I don't know what 8 to 12.8 reduces to. So I'm going to multiply both by 10 to get 80 and 128. Then let's see, we can divide by 4, I think, which gives me 20 and 32. Yes. And then divide again by 4 gives me 5 over 8. Yes. And they're all the same. So this is similar by side similarity. Now it doesn't give me any letters like A, B, C, D, E, F, things like that. So I can't set up the similarity statement, but just be ready for that. We did one of those in a previous video. Okay, number 2. Talking about one of the steepest streets in the U.S. In Seattle. If you measure horizontally 70 centimeters from a point on the road surface, so here we'll say is 70 centimeters, you must go down 14.2 centimeters, all right, to get back to the surface. All right, so I'm going to create that right triangle right there. And it says, what angle does Highland Drive make with the horizontal? So this angle right there. So I see that this is opposite side, this is the adjacent side, so I will be using tangent of theta equals 14.2 over 70. So because I'm solving for an angle, I'm going to write tangent to the negative first power of 14.2 over 70. So to get a rounded answer to the nearest tenth of a degree, I'm going to type in tangent to the negative first power of 14.2 over 70, which is approximately 11.5 degrees. 11.5 degrees. All right, so that is it for number 2. Let's go to number 3. Determine the number of years in 835,000 minutes. So I'm starting with minutes, right? And I want to go to years. So I'm going to go with minutes to get rid of that. And I'm going to go with, let's see, in an hour. So 60 minutes in 1 hour. Then I need to get rid of hours. And there are 24 hours in 1 day. And then I'm going to go with, there are getting rid of days. So 365 days in 1 year. So I'm going to go into my calculator and do 835,000 divided by 60. Then divided by 24, then divided by 365, which will give me the amount in years. So let's type this in. 835,000 over 1, and then I'll put times, do another fraction. We had 1 over 60, and then times, another fraction, 1 over 24, and then another fraction, times 1 over, and this last one was 365 days. So approximately 1.59 years. Oh, to the nearest tenth, so approximately 1.6 years. Okay, number 4. Find the area of the shaded sector if WZ is 3 meters. So this right here is 3 meters. All right. Now it's giving us that angle WZX is 108. So I'm going to use my understanding that if I look at this diameter, right, WY, right, then that means 180 minus 108 would give me the angle YZX, which is 72 degrees. So this is 72 degrees. This one is also 72 degrees. So for my shaded sector, right, I'm thinking about using my angles of 72 degrees plus 72 degrees, which is 144 degrees. So to find the area using my formula, it's my theta over 360 times pi r squared. So plugging in 144 over 360 times pi times the radius of 3 squared. Okay, so let's reduce 144 over 360. All right, I think this will take a little time. All right, so I'm going to first, let's divide by 2. That gives me 72, 180. Divide by 2 again, I get 36 over 90. Okay, I think I can up it a little bit. Let's divide by 9. 36 divided by 9 is going to be 4. 90 divided by 9 is going to be 10, and that reduces to 2/5. So keep going. So 2/5 times 9 pi. So my area is going to be equal to 18 pi over 5, and my units are going to be square meters. Okay, let's go to number 5, our very last one. We have the sides of a triangle are 5, 9, and 10. Is it right, obtuse, or acute? Show your thinking to support your answer. Well, I first know that this is a triangle because if I add any of the two sides together, they are more than the third side, right? 10 plus 5 is more than 9. 5 plus 9 is more than 10. Keep going from there. So I'm going to use my Pythagorean theorem to determine if this is going to be right, obtuse, or acute. Notice I put that little question mark above the equal sign to show that I don't know yet which sign it's going to be. So 5 squared plus 9 squared equals 10 squared. So that's 25 plus 81. Still don't know. Equals 100. 25 plus 81 is 106, which is greater than 100. And so when the two smaller sides, when those squares add together to be more than the hypotenuse squared, this is going to be an acute. It is an acute triangle. So again, if they're equal, it's right. If the hypotenuse squared is more than the sum of the legs squared, it is obtuse. And in this case, you saw number 5, the two legs, when we squared those and added them together, that was more than the hypotenuse squared. That is an acute triangle. All right, guys, that is it. All right, so I hope you're getting ready for the final finishing touches. Remember, be confident, do your best, and then I will see you at exam time. Good luck.